All right, so the start of this topic, there is two main sections to this topic. One section is on ratios and the other section is race. They are two quite different things, even though we put them into this topic together. A ratio is used to compare two or more quantities of the same type. Okay, meaning they have to have the same units, they have to be comparing the same types of things. A ratio is like a fraction, okay? Not exactly, we don't write it like a fraction, we write it with some dots to represent a ratio, but they are very much like a fraction. And the order that you write them in is important. So for example, if we want to know the ratio of girls to boys in the classroom, we say the ratio is 3 to 4, which means that there is three girls for every 4 boys. That's because that was the order that was mentioned here in the question. The ratio of girls to boys means the first number is the girls and the second number is the boys. Okay, see what I'm saying? So if it says girls to boys, girls is the first number, boys is the second number. If it said boys to girls, it would be boys first, then girls second. It's all in the wording of the question. Just like a fraction, ratios should be reduced to their lowest or simplest form. Like simplifying fractions, we're going to be simplifying ratios. A ratio is used to compare two quantities of the same type. A ratio does not contain any units. We should cancel or simplify so that they're in simplest form. The order of the numbers is important, and a simplified ratio can only contain whole numbers. You never want to go to decimals. It should always be the simplified whole numbers. We can write a ratio like this. It says A and B, but the A and the B would be numbers. So this is the 3.4, like the girls and the boys. This is the ratio, A to B. But it also means the same thing as a fraction where the A goes on the top, A over B. So you can write ratios as fractions and that actually helps you simplify them. All right, so let's practice. Example 1. Look at the cats and dogs below and then find the following ratios. Layla, shh. Listening, we can do that later. No. Question 1. So I want the ratio of cats to dogs. So the first number needs to be how many cats there are. Count them up. There's 1, 2, 3, 4, 5, 6 cats. So the first number will be a 6. Then I want some dots. Those dots are my ratio dots. Then I want the number of dogs. So count the dogs up. 1, 2, 3, 4, 5. So cats to dogs is 6 to 5. Then part B says dogs to cats. That means I want the dog number first, which was 5, to the cats, which is 6. 5 to 6. So the order is important. Cats to animals. We know that there was 6 cats. Animals means the total number of animals that I have here, which is 11. Good. And part D, animals to cats. There is 11 animals in total and cats was 6. Just reversing the order. Okay, pretty simple. Let's go to question 2. For the diagram shown, write the following ratios. Part A, we want shaded parts to unshaded parts. So there is 5 shaded parts in that diagram, so that will be the first number. Dot, dot. Unshaded parts, count them up. 1, 2, 3, 4, 5, 6, 7. So 5 to 7. Unshaded parts to shaded parts, it's reversing the order. There was 7 unshaded parts to 5 shaded parts. And C, shaded parts, which was 5, to total parts. That means I don't care if they're shaded or unshaded, I just want to count up how many there are, which is 12. Good, done. Question 3. For the 26 letters in the alphabet, A, E, I, O, and U are called vowels, and the remaining letters are called consonants. Write down the following ratios. So vowels, how many vowels are there in the alphabet? 5. And to consonants, how many consonants are there? If there's 26 letters in the alphabet, 5 are vowels, 21 are consonants. Part B, consonants to vowels. It's reversing the order, 21 consonants and 5 vowels. Part C, vowels to letters. There is 5 vowels. When it says letters, it just means total number of letters in the alphabet, which is 26. And letters to consonants. There is 26 letters in the alphabet, and 25 of them, no, they're not, 21 of them are consonants. Okay. Everyone okay so far? Great. Question 4. Rewrite each of the following statements as a ratio. So in words, it says 3 centimetres to 5 centimetres. When you see that word 2, that's where your 2 dots go, right? So it's going to be 3 centimetres to 5 centimetres. As long as they are both in the same unit, i.e. centimetres, you don't need to write them. It's just 3 to 5. Okay, that's it. That's my ratio, 3 to 5. If they are not in the same units, I'll have to change them. So that's going to be coming up. Part B, $5 to $11. They're both in dollars. So we're just going to go 5 ... 11. Question C, that's where it gets more fun. We have 51 cents to $1. So let's do this in a couple of steps. 51 cents ... $1. Because they are in different units, I can't take those units away until they are the same. So it's usually easiest if you change the bigger unit into the smaller one. So the bigger unit is dollars. Dollars are bigger than cents, right? So there is 100 cents in every dollar, so let's change that to 100 cents. So it'd be 51 ... 100, and I no longer need to write cents because they are now both in the same unit. Part D, 21 centimetres to 1 metre. If you prefer, you can actually do your converting here first. You go, all right, 1 metre, I want to change that into centimetres. What is it? 100. It's 100 centimetres. There's 100 centimetres in a metre. Okay, make the units the same. I don't mind if you do it in a ratio or if you do it beforehand, but make sure they're the same and then write your ratio down. 21 to 100. They're both in centimetres, so I don't need to write the centimetres in. Question E. 5 weeks to 1 month. This is a little bit sneaky. Don't really like that. Because how many weeks are in a month? Yeah. It varies. That's why I don't like it. We could change them into days, but even if I went to days, then there's different numbers of days in each month, isn't there? Maybe we'll just have to go approximately. We'll say there's approximately 4 weeks in a month, because otherwise it's not a very good question. All right, so we'll change 1 month is going to be 4 weeks. So that's the same as 4 weeks. Just remember that's not completely accurate. Only February has exactly 4 weeks. The rest of them all have another day or 2. So it's going to be 5 weeks to 4 weeks. It's best we can do because each month is just a little bit different. F, 3 girls to 7 boys. Can we change girls into... Okay, I should ask that question. Okay, no. They are the same unit. That just means people, okay? So it just means people. So we don't have to try and change anything there. The ratio is simply 3 to 7. No, forget I asked that. We're not going to go there. That was a very silly thing to say. Okay, question 5. Complete each of the following equivalent ratios. So I'm going to give you a starting ratio, and we can make ratios bigger by timesing by something, or sometimes you can make them more simplified by dividing. They'll always be given one of the numbers so that you know how to change them. So if I'm given the first position, how do I get from 1 to 5? You either need to multiply or divide. If it's getting bigger, you're going to be multiplying. So I have to multiply that by 5 to get from 1 to 5. That means to work out this missing number, I have to multiply this second number by 5. So what is 4 times 5? That missing number is going to be a 20. All right, let's go to the next one. Again, I have the first position, so I'm going from 1 to 3, which means I have to multiply by 3. So then I take the 7, and I'm going to have to multiply that by 3. 7 times 3 makes 21. Part C. We're starting with the 5, and it's turning into a 1. It's getting smaller, which means we divide by 5. Okay, don't ever try to add or subtract, okay? It's either multiplying or dividing. So the 20, I'm going to have to divide that by 5 as well. 20 divided by 5 is 4. D. 2 to 6 is getting bigger again. So I have to multiply by 3. 5 to get to something, I'm going to have to multiply that by 3. 5 times 3 is 15. You use the first ones to work out the number, and that tells you what you do for the second one. So I knew to get from 2 to 6, I had to multiply by 3 to get from 2 to 6. So that means I have to multiply the 5 by 3 to get 15.
How do you get 3?
By knowing your times table. So you look here, look at this one. This time the 6 and the 2 are in the same position, so tell me. It's either dividing or timesing. So I'm going from 6 to 2. How am I going to get from there to there? Joey's the only one telling me. From 6 to 2. Divide. By what?
Hey.
No, don't listen. They don't know what I'm talking about. I have to divide by something to get to 2. 6 divided by what makes 2?
6.
No, 6 divided by 6 makes 1. 6 divided by 4 doesn't go nicely. Get your calculator out. 6 divided by what makes 2?
3. I still have no clue what's going on.
So you're going to get your calculator out and you're going to start looking for things. Start with 6. You go, what am I going to divide 6 by to get 2?
2.
If you divide by 2, what do you get?
What do you get? 3.
That's not the right answer. I want 2.
What are you saying? Right? Oh, yeah, so it's 6 divided by 3 is 2. You got to put 3 in the place.
So what you want to do is you want to divide it by 3, because type in 6 divided by 3.
2.
And that's the 2 here. Okay, so if I divide that by 3, I have to take this first number and also divide that by 3. 27 divided by 3 is 9 for the first number. Now this process works, guys, for ratios with 2 numbers, but ratios, boy, there's a lot of chatter. Ratios can have more than 2 numbers in them. This one has 3. It still works here. So what I want to do, my first number is a 4 and it started with a 2. How do I get from 2 to 4? How do I get from 2 to 4? It's getting bigger, so times by what? 2.
4.
2 times by 2 makes that 4, right? So that means the 3 and the 5, both of those numbers need to be multiplied by 2 as well. So 3 times 2 makes 6, and 5 times 2 makes 10. That's it. So that is what we call equivalent ratios. Question 6. 6 and 10. All right, question 6. There are 10 parents, there are 28 students, and some of them are talking. Oi, people in the back. Not now. We need to do this, otherwise you're going to miss on the next question. There are 10 parents, 28 students, and 6 teachers at a school function. Write down the ratio of parents to students. So parents, I've highlighted the 3 important numbers. Parents, there are 10 of them, so my first number is going to be a 10. And then I want the ratio to students, and there is 28 students. Now, for practice, although I'm just having a sneak peek ahead, we're going to spend a lot of time doing this next lesson. If you want to simplify a ratio, you want to try and divide both numbers by the same thing, but they're not allowed to go to decimals. They have to divide nicely. Can you think of a number that you can divide both 10 and 28 by? 2, all right? If I divide 10 by 2, I get 5, and 28 divided by 2 is 14. Okay, so this is the ratio, 10 to 28, but this is a little bit of what we're going to be getting into, simplifying the ratios down afterwards.
If we divide in our test, will we be graded down if we did simplify?
If the question tells, there will be questions that will say to simplify the ratios, and yes, you absolutely must simplify them down. Part B, write down the ratio of teachers to students. So teachers was here is 6, there is 6 teachers. And students, there is 28. Let's have another try here. Look at those 2 numbers. What can they both divide by? Cash again. 2 again. So 6 divided by 2 is 3, and 28 divided by 2 is 14. One last one. Write down the ratio of students to adults. Students, there are 28. Adults is both the teachers and the parents.
The students could also be adults.
I think we're assuming we're in high school here.
Yeah.
We're gonna go with just the parents and the teachers, but you're right, I guess the question could have been clearer. But you are right, students can be adults too. 10 plus 6 is going to be 16 is how we're gonna answer this. Now somebody else other than Cash, what can I divide by here? Go on, Joey. You can divide by 2, but can anyone give me a bigger number? Someone other than Cash. Cash knows all the answers today. 2 does work, but to be as simplified as possible, you want the bigger number, the better. So tell me a bigger number. No, he already told me 2. Somebody else.
He's got another one.
Another 4. Ignore that.
He's got a bit.
Joey.
I've got it.
4. Spoilers. Okay, 28 divided by 4 is 7, and 16 divided by 4 is 4. We're going to be spending a whole lesson on the simplifying stuff next lesson. This is just a little taste of it, and I am going to show you how to do it on a calculator. It's a bit of a check as well. But just a little introduction there. All right, one last question, and this one is the one that I'd probably give a bit of a star to. This is the harder type of question here. All right, let's read it. On their way to work, Andrew passes 15 sets of traffic lights and Pauline passes 10 sets of traffic lights. One morning, Andrew was stopped by 12 red traffic lights. How many green traffic lights? Boy, too many reds and greens, a bit confusing in here. How many green traffic lights would Pauline need to pass through to have the equivalent ratio of green to red traffic lights as Andrew? Sometimes it's just the wordiness of the question that confuses people. What does this actually mean? All right, we have got 2 different people here. We have got Andrew and we've got Pauline. And they're both driving off to work. And they're going to go through red and green traffic lights. However, I'm not told the red. I'm told some red traffic lights, but I wasn't ever told any green ones. So what I'm going to do for my ratio is I'm going to do the total number of lights that they go through to the red traffic lights. Okay? So for Andrew, read back through the question again. Read back through the question again. On their way to work, Andrew passes through 15, there's that number, 15 sets of traffic lights. That's his total. His total is 15 traffic lights. And then it says Pauline passes through 10 sets. We can put that down while we're at it. Pauline down here passes through 10 sets of traffic lights. One morning, Andrew was stopped by 12 red traffic lights. So red, he passes through 12 of them. The trouble is, that's it. They're the only numbers that I've been given. It then says how many green traffic lights of all things. Let's not worry about the green for now. We need to find this missing number for Pauline. The trouble is that these don't quite go so nicely. Okay, you can't really times 15 by something to get to 10 without going into weird decimals. So what we could do instead is we could simplify this ratio down. All right, Cash, what do I do? Divide by what?
5, 10, and 15.
I don't know. I thought you were going to something else. No, not yet. So if I want to simplify this ratio, look at those two numbers. I could divide them both by, you got to tell me now?
3.
3. They both divide by 3. 15 divided by 3 goes 5 times, and 12 divided by 3 goes 4. That makes a much nicer ratio to use because from that ratio 5 to 4, I need Pauline to have that same ratio down here. So this is kind of like, this is the box, and I'm going, how do I get from there to there and to there to there? So if I get from 5, can I times by something to get to 10? 2. That goes nicely. I times that by 2. Which means the 4, I'm going to times that by 2 as well to find that number, which is going to be a times by 2. I heard someone say it. 8. Good. But what is that 8? It was 10 traffic lights that she went through. What does this 8 represent?
Yeah, the red.
The number of red lights. The question actually says how many green traffic lights must she go through? How many green lights is she going to go through? 2. Okay, so there was 8 red. She had a total of 10. 2 of them had to be green. Okay, so at the end there I'd go, therefore, 8 red traffic lights, which means or 2 green, which is what we're actually after. Okay, so you can see why that was a little bit of a challenging question. Our ratios didn't match together very nicely, and now we're mixing us all up with the red and the greens going on in there as well. Okay? Probably not. Okay, so your questions start here on the next page, 5A. And you want to write down the ratio of the shaded part to the unshaded part for each grid that you see there.